All right, everyone, welcome to the October Valorem Databricks user group. My name is Spencer Cook. I'm your host as always. I'm a Databricks certified engineer and a Databricks champion. I work in the data-driven enterprise group at Valorem Reply as a data strategist and data scientist. Today, I'm kicking off a new series that I think is going to take us through the holidays, Databricks 101. So we've so far talked about some advanced and intermediate topics in Databricks, such as structured streaming, Delta Lake, ML Flow, et cetera, data lakehouses. And I kind of want to go back to basics and give a baseline that answers the questions that some people may be too afraid to ask or not even know they needed answers to. So let's go ahead and dive in. So the agenda for today is going to be deploying an Azure Databricks environment and then going through some of the basic tasks in Databricks and talking about how to run Spark jobs and some things like that. And then we'll go from there in the next couple months. So let's go ahead and create our Databricks instance. So Azure Databricks is just like any other tool within Azure. It's available on the Blade. I have it at the top here because it's a frequently used resource for me. You can also go to this Create a Resource panel, and you can just search for data. And there's not a whole lot of configuration that's needed. You just create it, and then we choose a basic plan and a resource group. I'm going to create this in my Visual Studio Enterprise instance. You can also, create it on one of your enterprise subscriptions. I'll just call this October VDUG. So I can clean that up later. And then same thing here. Just give it an easy to find name. I typically choose either a region with high availability for the task I'm using or one that's close to me. In this case, I'll choose South Central US. And then the only difference between each of these tiers, obviously trial is going to give you some free DBUs for a few days. The big difference between standard and premium is getting RBAC roles. If you don't know what those are, you can probably do without them. But for any enterprise deployment, you're going to want to go ahead and do premium. You cannot actually upgrade later. So if at any point you're going to want to have role-based access controls that are backed by Azure Active Directory within your Databricks instance, you're going to want to go ahead and choose this. In this case, we're tearing this down right after I create it, so I'm not going to do so. Now you could do review and create and be totally fine. I'm going to walk you through some of the other options available here. So you can deploy an Azure Databricks workspace in a VNet if you desire. This is going to allow you to have network privacy for your Databricks instance and have it operate within a subnet. If you want to have sort of a DMZ style data infrastructure where none of your data stores are available, to the open internet, then this is definitely the option for you and what you want to do. You can also integrate this into an existing VNet architecture. For instance, if you're working with a software project or a web app that wants to start using some of the features of Databricks. As always, you can do some of your tagging within Azure to label the service. This can be useful for billing, etc. And then we'll finally go ahead and create this. So I should turn this back off because I don't want to fill it in. And then I can go ahead and create this. And then we'll track the deployment process. But similar to, any good cooking show, I've already baked the item ahead of time. So we'll go ahead and jump over to that. So once this is done deploying, you would have it available in your Azure Blade, and you could go into your Databricks instance and go into Launch Workspace. Now, there's a couple of other options here for quick starts, like importing data from a file, importing from Azure Storage, linking to an Azure ML workspace. I'm going to dive into some of those features in later sessions, in addition to access control features and some of the other, more advanced enterprise features. But for the sake of our 101 discussion today, let's just go ahead and hop right into the workspace. So once you get into the workspace, you're going to have a variety of options here. So over in our main tab pane, you'll see a Databricks icon, home, workspace, etc. We'll dive into each of those. The first thing I want to call out is this quick start tutorial. Now, a lot of times these can be a little silly or not that valuable. I think this one's actually pretty good. So let's go ahead and dive into what that looks like. By the way, I'm going to move my Teams chat over so I can see it. Feel free to post in the chat, and our moderator, Lindsay Rain, will let me know that there's a question, and we'll go ahead and address it. So the first thing that we're going to want to do is create a cluster. Now, clusters are really the bread and butter of what Databricks is doing. So it kind of depends on what background you're coming from, but the main reason that a lot of people I speak to have gotten interested in Databricks is largely because of how complicated it is to create and maintain a cluster, either using even software as a service architecture or a classic VM on Azure. Having this sort of platform as a service layout is really what's made Databricks expand to the valuable product it is today. So when we click Create Cluster here, and similarly to some of the other topics, I'll dive into job clusters and pools in a later session, but we're going to start just by creating a cluster. And we'll go ahead and call this Quick Start. And what this is doing is creating a Spark cluster that's hosted on Azure Compute. So if you're an architecture nerd or just spend a lot of time working with Azure, you'll notice that these SKUs are the same as any other compute SKU within Azure. So we're essentially just choosing the type of compute we need, usually differentiated by memory, core size, and how many DBUs it's going to consume. But they also have a couple of Databricks specific configurations. So you'll notice down here, we're going to have some memory and storage optimized SKUs. The memory optimized has more RAM than is typical for that core size. Since Spark is an in-memory computation service, that lends itself nicely to some of the paradigms that you expect from typical Spark work. Similarly, storage optimized is Delta cache accelerated. So you're going to get Delta cache built in to your cluster. That's one of the new features that's coming in or came from the Databricks Summit this past summer with Spark 3. So essentially what this is doing is taking advantage of high throughput disk storage along with the Delta cache service to go ahead and create accelerated Delta tables on top of your Delta Lake, which is a big part of the new Delta Lakehouse paradigm. And then finally, you'll see that we have some compute optimized. So if you know you're going to be dealing with small tables, but you want high throughput, I would suggest those. And then GPU accelerated. Typically, that's something where you know you need it if you need it, but these are really popular for deep learning and those types of tasks. So we're ready to create our Spark cluster. If we just click Create Cluster, everything else I would leave at default, including the auto scaling. Now I am going to turn down our max workers here. You'll see a notice that we don't even have enough CPU cores allocated to this particular Databricks instance. If you ever run into that, it's actually pretty easy to file a support request and get that extended. But for now, we'll just leave it at 2 and 3. And that should give us enough clusters. And so we can create that. And you'll see it's going to automatically start up. Now this interface is what you get to if you go back out to clusters and you click on any one of these rows. And this is where you can manage a cluster. So really what you're doing is just managing a Spark cluster in the same way you would if you were running it on a traditional Linux Hadoop machine. And so you even see we have tabs for things like the Spark UI and the event log, anything you'd expect from a normal Spark instance. Now let's jump back over to our Quick Start notebook. So we've created our Quick Start cluster. Now, how do we attach this notebook to it? Well, here in the top left next to our cluster icon, we can go ahead and click or select a cluster to attach to. I think I need to refresh this to make it know. So if I click on this, I can see Quick Start showed up. So this attached my notebook to this cluster. Now, once it's attached, I can go ahead and click on Run All, and it's going to wait for the cluster to finish spinning up and then run all of the commands in this notebook. Now, I want to go ahead and walk you guys through the commands that it's going to run instead of waiting for the cluster to fire up, because we've got plenty to cover today. So the first thing you're going to see is some SQL code. We really only know that because it's in the Spark SQL syntax, but there's another hint. Up here next to our notebook name, we can see SQL. Now, you'll notice it's a hyperlink. That's because if I click on this, I can change the default language for the notebook. Now, in this case, it's SQL. You can also add what they call magic commands, which is a %, and then any one of these magic commands, including SQL, Python, R, file system, etc. And that will make it so that you can run the polydactic language features within a notebook. So for instance, I can run Python code within my SQL notebook. So the first thing that we do in this, they call it a SQL block or a command, is drop a table if it exists. And this table is called diamonds. Now, the reason we're doing that is because the immediate next thing we want to do is create that table. And we're creating it using a CSV file format, and we're providing a file path. Now notice, this kind of looks like a location within a file path. Like essentially, if we had some sort of mounted storage, like C on your Windows computer, or user or something like on your Linux machine, this is not a full file path. Well, that's because this is coming from the Databricks file system. So typically, for your Spark clusters, you have storage completely decoupled from compute. One of the other things that Databricks Platform as a Service offering gives you is a built-in file system that's hosted at the same HTTPS endpoint as your Databricks storage. So that's sort of the exception to the rule. So when this runs, it's actually going to be going to this built-in data set from Databricks, and it's going to be pulling it in and creating a table. So you'll see now that this is running, and you can see underneath the jobs that are happening along with their stages. This is another, Spark UI component that you might be used to if you've done traditional Spark work on a local cluster. And then once this table is created, we can select from it just like any other. And we can see that we now have this table registered. And then we're going to run a Python command to do the same thing. So in this case, we're creating a data frame called diamonds. And you'll see down here, it's going to have the same rows and columns. Now, the reason that we're pulling it into a data frame is because the next thing we want to do is use the Python or PySpark library for write to go ahead and create a delta table. So we're going to format it as delta, and you might remember this from our Delta Lake discussions. We're going to format it as delta and then save it to this root file path under delta/diamonds. and that creates a delta table. So then we can go ahead and replace this table, which is backed by the CSV file that we created. Because literally when we query, for instance, select star from diamonds, it's actually pulling directly from this CSV. It's just using a Spark transformation in between, because that's the file format that we specified. Well, here, when we recreate it using Delta at this location, it's going to instead be backed by the Delta storage format, which is a highly efficient columnar storage format created in collaboration with the Spark team specifically for this type of task. So then when we select, we'll see the exact same output as expected. Now I want to point out this took 9.18 seconds. And then when we pulled it from the Delta table, it took 8.22. You know, not a big deal at first, but as your data volume increases both both horizontally and vertically, this is a really important optimization. So now that we have our Delta table in place, we can go ahead and run a command to manipulate this data. Now, this is one of my favorite features of Databricks notebooks. So we're doing a SQL command again. We're just grabbing some color. We're doing some aggregations for average with an alias for price from diamonds and doing a basic group by and order by. And that's what gives us this output. Now, in any cell that returns data, you'll notice this button up here as well. In any cell that returns data, we can click on this chart icon and it will try and automatically infer what kind of chart might make sense for this data. In this case, we're seeing the average price by color of diamond. But we could also, under plot options, modify the keys and modify the type of chart. And we can change our aggregations as well. Like if we hadn't done an average here and we wanted to do one, or a sum. You can also quickly change this into, say, being a scatter plot, or sorry, let's do maybe a pie chart instead. So that's the baked in graphing features that are on top of all data sets. You can also do an export from right here. Now, Databricks recently acquired a BI tool that is going to be integrated into the UI as another one of these tabs. And I think it's going to work great as a further extension on top of this graphing utility. So I'm looking forward to that. I think it's in private preview right now. So that is the charting interface. Now, I also want to show how we can create a data frame from a Databricks data set. So if we go ahead and run this command, you'll see that we get a data frame back. And this is from an internal data set, just as before, right? And this will do the same thing to manipulate the data and display the results. Again, the difference is up here, we were doing it using SQL. Where was I? Right here, we're doing it using SQL. The same interface can do it in Python as well. And you'll notice both of them had the exact same stages, or sorry, exact same jobs and stages. That's because the interpreter underneath the Spark Quest engine processes this high-level API for either PySpark or Spark SQL and turns it into the same Java virtual machine runtime on the back end. So instead of the user having to decide which API should I write this transformation logic in, like which is going to run the most efficiently, instead you can write in whatever language you're most familiar with or suits your particular task, and then trust the Databricks runtime to do the optimization for you. So that's sort of an introduction to some of the options we have available with clusters, everything else. Now, I want to take a step back and dive into some of this a little bit further. So you'll notice at the top left, our Databricks icon. Anytime you click that, it's going to take you back to this sort of home page or landing page for Databricks. So that is different from the home icon. So you might typically think of like home as taking you home, right? In this case, it's taking you to the home folder for your particular user. So this is where our quick start notebook that we just created lives. Whereas this, again, takes you back here. So let's go ahead and create another notebook so you can see that again. So if I click create a blank notebook here, I'll get the option. Let's just do October VDUG. I'll get the option to choose my default language here. And like I said, you can choose between Python, Scala, SQL, or R. Fingers crossed that .NET is coming, but I haven't heard a timeline on that yet. So we'll go ahead and create this one as Python. In quick start as before. So this is what a notebook looks like by default when you create it. And again, you have the same interface to attach to clusters. So for instance, if one cluster maybe had different permissions, or if it was busy, maybe it has a higher compute, we can switch between them. You also notice that this is on the Databricks runtime 7.3. This default cluster I've been using for my YouTube live streams is still on 7.1. So you can have different versions of Spark, different versions of the Databricks runtime, and even different versions of Python or Scala, all within the same interfaces, and you just decide which to run your compute on top of via this cluster interface. You'll also notice we have some pretty standard interfaces for working with these types of files. So under File, we can do things like clone, rename, move. There's also a new feature for upload data. Now, we're going to get into this later, but if we went back to the home screen and clicked Import and Export Data, or went to the Data tab and clicked Add Data, they all take you to the same place. This is just sort of a quick shortcut. So if you wanted to, within, say, a notebook that you're doing exploratory data analysis on, instead of hopping between different pages, you're going to have a nice interface to bring in the data right there where you are. And this is another reason I think Databricks has gotten so popular, is things that people intuitively know how to do, but take extra steps, are now made very straightforward and built into a nice, clean UI. Similarly, under edit, you get your typical cut, copy, and paste. You can have it automatically clean up SQL. You can do find and replace. I call this out because it took me far too long to remember that there was find and replace in here. You can also change the view. So if we go back to this quick start notebook, this will be a better example. We can see results only, for instance. So if we wanted to present this to a client, we could have an output that only shows our markdown cells and then our output cells. It's not showing any code. We've all probably had to deliver something to someone in the C-suite that, when they see code, they start to break out in hives. So, this is a nice way to show that. You can also do side by side. So we can have markdown per cell and see sort of the output of each cell next to it. And then finally, this is one of the cool tricks that took me too long to learn, a dashboard. So if we want to, each cell is going to automatically be turned into a cell within the dashboard. And so for instance, I could remove these. I could expand these so that you can see everything. Let's go a little further, etc. I can also change the width. I can either remove all graphs or leave them. And then finally, when you're done, you can present this dashboard, and it's a nice consumable format. And since this is backed by a Databricks notebook, anytime you click update, it will rerun those cells, assuming it's been attached to a cluster, and it'll rerun those cells and update the view. So it's sort of this more ad hoc style of Power BI almost. And again, you would attach it to a cluster the same way that you can attach a notebook. So that's the idea of creating a notebook. We'll come back to that. I want to dive back into the cluster interface real quick. So within this, I pointed out some basics when you create a cluster. I want to point out some more details here. So, and we're not going to create this, so I'll just call it default for now. So under cluster mode, you'll see a couple of options here. And if you don't, take notes on this explanation, you can get back to it just by hovering over the question mark. So high concurrency is essentially a cluster pool. Basically, there is a set aside amount of Azure compute that's reserved for Databricks. And so by opting into the high concurrency mode, your clusters spin up faster, are a little bit cheaper, and also support Azure Active Directory credential pass-through by default instead of you having to configure it. Now, the downsides are they only support, and you can see this here, they only support, come on, if my mouse would hang out for a second. They only support SQL, Python, and R workloads. They don't support Scala. They used to not support R either, so Scala might be coming in the future. But think of this as serverless, kind of like an Azure function. And then finally, there's the single node compute. So notice down here we had our worker and driver. If we go into single node mode, it's only going to have a single node. So this is really great for like ad hoc data science. So there have been times where I'll create clusters, default 1 through 5, and they're all running different tasks in parallel. And if one's busy, I can hop to the other. But it supports sort of the ideal version of an ad hoc workflow where the computer is always waiting on the user instead of vice versa. So I'm not blocked by my compute. The whole point of having a platform as a service offering on Azure is so that you can just rapidly spin up or spin down or spin to either side the amount of compute you need. Similarly, when we go back into standard mode, you'll see I can associate this to a cluster pool. Now, we haven't created one yet, but essentially what that does is allows you to have a continuously available pool of clusters. And so default might share from the default pool, which always has 4 clusters running. And so that way an individual user can share resources with, for instance, their team. Next, you'll see, like I was talking about earlier with the different SKUs down here, you'll see that we can also choose our Databricks runtime version. So if, for instance, the 7.4 beta, which was just announced, has some features that you're really looking into, for instance, for like off the top of my head, they added some cool features for data governance on Databricks Delta, right? You can opt into the 7.4 beta. You can also opt into ML supported configurations for either of these two, both GPU and non-GPU backed. And then similarly, if say version 7 broke your SQL Server connector, not that that literally happened to me, but say it did, you could roll back to 6.6 on top of Spark 2.4.5 instead. And you'll see that there are several long-term support versions in here as well that have, I think it's a guaranteed 36 months worth of service. So a variety of options for your runtimes and your compute. We can also turn auto scaling on or off. And you can also set up automatic termination. So those are sort of, I also want to jump into the advanced options real quick. So I've talked about credential pass-through. So when I click this, I can grant access to a single user, and that user is the only one allowed to run commands on this cluster. But what it enables is any user that has access to, for instance, our data lake storage or a SQL server, anything like that that's backed through Azure Active Directory security, instead of having to configure token access or handle any complicated integrations with your backend data sources, Instead, this cluster passes through your Active Directory clusters, authenticates to the Azure Data Lake, and brings your data back through automatically. So pretty cool. I explored that quite a bit in my Mixer streams if you want more insight, but it's a really nice feature that I want to make sure and call out. And then finally, you can do some basic configuration like your environmental variables if for some reason you wanted to be on Python 2.8. We'll talk more about this stuff in detail in a later session, like I mentioned. So the next thing I want to look at back on our home screen is creating a table. So in our quick start, we looked at how to do that programmatically. I want to look at how to do it in the easiest way possible as well, because sometimes you really don't need to do anything fancy, right? So I'm going to bring over my file explorer here. And so this has a CSV pull that I pulled from the same API I've been using for my live streams. And so I can just drag it and drop it into that box. It's going to upload the CSV. And then I have the option to either create a table with UI or in the notebook. Now in this case, I'm going to do the UI because again, I'm keeping it simple. Now I select a cluster because it does need compute to be able to preview the data, right? You don't get anything for free. So codes, I'll point out, you can change the table name. By default, it's going to use the file. Oh, it wants lowercase. That's on me. And I can choose to create it in the database or not. Now the options here aren't really relevant to us. We only have a default database, but think about the way like your typical like either SQL Server or data warehouse might work, where you have different schemas or even different databases within the same server. Same deal here. So you can actually create multiple Hive databases. I'm just using default, like I said. File type. So if for some reason it didn't infer it or you're using a custom selector, you can pick that from here. You can choose your delimiter. And then in our case, we can see the first row needs to be the header. And since everything's coming in as a string, we're also going to infer the schema. That didn't seem to help us very much, but oh well. We can change that later by modifying the D types. But if I wanted to, I could make it clear that, for instance, this needs to be a float, for instance, and then IBU needs to be a small int. At least I hope the IBU isn't a big int. And then we can go on from there. And so if I went ahead and created the table, you'll see here that it's now registered as a table and it has this sample data. Now I want to go ahead and call out over on this data tab, you can actually see all of the tables that you created within a specific database. So I can see this beer info table, which we just did a quick create, or I can click on any of the tables that I've created during the course of our streaming sessions. Now, and let me go ahead and pull both of these up so you can see the comparison. I think it's because this other tab is using it. Let's go back over here. So you'll see that what I wanted to call out is we have a number of files and a size here, right? We can also see a history. That's because these are delta tables. And so we can literally see which updates happened on the table. So if we went back over here and, for instance, chose like our fact table, Databricks seems to be a little unhappy today. Oh, I know what happened. I actually cleared some of these out of my last stream, so they're not going to be available. But if we went back over to the beer info, we would see that it doesn't have that history table, doesn't have any information on the data lake, because it's not being stored there. It's just stored as part of the Databricks file system. So that's sort of the difference between a table that is registered with Hive on Databricks versus one that's registered with Hive and is also backed by Databricks Delta. So I want to go back over to this data tab, and I want to show you something else. So if we click Add Data, we can also connect directly to Azure Blob Storage, Data Lake Storage, Cassandra, anything with a JDBC connection, Kafka, etc. And so what you would do, for instance, is click Create Table. And you'll see here that it sort of walks you through the process of adding in a storage account name and a token, setting up a file location, and then reading in the data. So it has the capability to read in file formats or from sources outside of that small list, but these are ones that it has sort of built-in example notebooks for that really guide you along and make it easier to ingest that data. Then I also want to show, and this is really helpful for people learning Databricks, if we click DBFS, you can also see that, like, for instance, for where is it, under user, sorry, under, I'll post it in chat if I can't find it. Yeah, there's some built-in data sources like we saw in the quick start notebook under Databricks data sets level, but there's a ton of really nice data sets that you can bring in to start playing around with so that you aren't, struggling to connect to a data lake, just so that you can start doing some tutorials. So that's the data interface, and that's how you can see like your delta tables and some other stuff going on there. And like I mentioned, all the stuff that's being created in this Delta tab under this database, that's what I've been doing in my YouTube streams. It used to be on Mixer. That's why, like, for instance, it's called Mixer Workspace. But that's what I've been building there. So if you want to see more insight into how we've created those and what's going into them, catch up on the YouTube backlog, or come check out the streams at noon on our YouTube channel. So jumping into the next part of the interface. So this is pretty basic, but it's also pretty cool. So we can click Create Job, and this is going to just automatically run or let's call it Quick Start to be consistent. And this is automatically going to run a specified notebook at a specified time. So for instance, like, we could run our Quick Start notebook. And so for instance, like that dashboard that we created from Quick Start, it would keep this fresh. You can also add parameters to it. So for instance, if it runs on a certain day or for a certain user, and you can also add dependent libraries, which we're going to talk about in a second. And then finally, you can edit your schedule. You can do this either using the UI or using cron. I typically just use the UI. So we could say do it every day at 3 a.m. Pacific, for instance. And then this is going to run. Under advanced, we can also set up alerts, like if you want an email, if you want it to run concurrently, do retries, if it needs a certain set of permissions, for instance. So pretty robust. Now, under a job that's already been created, I can see a run history. Like, we can see job failures or successes over time, right? So you can see that I've been doing some work on the nightly jobs that isn't quite done yet for our data lakehouse. So pretty nice stuff there, and it's certainly a lot easier than trying to orchestrate a Spark job through your Linux box. Next is models. So this is where you can create and register ML models. We looked at this kind of in depth in the ML Flow Databricks user group session, but I just want to show again how easy this is. So if we create a model, we could call this Quick Start as well. And it creates this new model interface. So we can register this with the ML flow code that we're creating. So for instance, if we created like a classifier model, it's going to get registered here with the appropriate tags and values. And we can also see the different versions. So like we talked about in that session, that you could have, your dev, staging, and prod versions of the same model, and you could choose which gets deployed to what stage. You can also now enable serving. So if we go ahead and enable this, this is what's going to let you have a REST API from which you can query your model and get immediate feedback. So instead of hosting it on Azure ML, you can do sort of your ad hoc analysis or evaluation of the model here. Similarly, if we go back to the home page, we can create new MLflow experiments from this main landing page. So we'll call this one. Well, we can specify our artifacts to either go to like a specific data lake store or external source that we mounted. If we leave it blank, it's going to go ahead and default and just store on the Databricks file system, which works just fine. You're just going to be a little storage limited. So we can go ahead and create that. You'll see here we have our nice MLflow tracking interface with our experiment ID, everything else. If there were any runs in here, we could go ahead and search them. And then you'll see that this was created as an asset under our home folder, right next to everything else as a quick start notebook. The only other thing I want to call out on these main tabs is search. So for instance, if I'm trying to find a specific notebook, I could search for silver as a name. I can also go under recents and see some of the notebooks that I've been using recently. So just some, UI tricks that are probably fairly obvious, but if you're not in Databricks all the time, aren't necessarily going to occur to you. And then the last little thing is importing libraries. So this doesn't seem like a big deal until it is. There are a number of machine learning and scientific modeling libraries that are integrated into the Databricks runtime. But let's say you're doing something new, or like in my line of work, we're regularly working with proprietary data formats. Having an interface where you can upload libraries similar to what you do with pip or PyPy or Maven, all built into Databricks, is huge. So you can either upload jars, Python eggs, or wheels. So for instance, I've got a couple of jars, I believe, in my downloads folder. Or maybe not, I think that's on my other box. But I would just drop them right in and it would install. I can also use a web interface. So PyPy packages available. So if I want to go ahead and browse, like I could see these trending projects, I can install the nightly build of TensorFlow, or I could install this hot new Bitcoin library. So if I click on this and grab, I think I just need to grab this name. And I could specify the version too, but I could go ahead and create this as a library, and it's going to install into whichever cluster I choose. So I could install it into Quick Start from there, and then whenever I want to work with build L or WID-L, Whittle, I could have that available as a library within Python to reference. And so having this like fully extensible environment for both Python and Scala and R that also supports easily managed Spark as a service is a huge component of completing the circle and making this like a robust programming interface for not only Spark, but the complete data engineering and data science and data analytics lifecycle. So that's sort of the top level topics I wanted to cover in this Spark 101 session, just to kick off this new set of talks. I want to go ahead and open the floor to questions both about what we've discussed today and also Databricks more broadly. So I'll go ahead and stop my screen share. Just let you see my pretty face. If we have no questions, I'm more than happy to give everyone some time back.
Well, I have a question. This is really I'll take it offline. It's very basic. I just want to see how I can access Databricks. I've never accessed the,
No, that's a great question. So we actually looked at it at the beginning of this session. So I want to go ahead and repeat it. No question too basic. This is Databricks 101, So over here in Azure, what we did to start was in the Create Resources blade, if you just search for Databricks, go to Azure Databricks, click Create, and then it's as simple as assigning it to a resource group. So I'll go ahead and create another new one.
Okay, I was just wondering if you had if there was a resource group that you were working off of that I should look at.
Oh yeah, so there's a couple. Yeah, we can take this offline because there's a couple proprietary to Valorum, but you'll if you go up to Home and then click on Azure Databricks from here, you can see some of the existing Databricks environments that you have access to and the appropriate resource groups.
Okay. Yep. So I have access to none. Okay.
Well, no, you should have access to any of these that are in Digital Insights.
Okay.
Well, we can figure it out.
Yeah, please. Yep.
Yep. Cool.
I am curious about how the pricing structure compares from just flat storage to clustered storage. Is it exorbitantly
so that's the thing. So the compute and the storage are completely separate. So your data lake storage costs exactly as much as it would if there were no Spark involved at all.
That's very cool.
It is very cool. And similarly, the Databricks SKUs, like I was showing, it actually costs the same to run Databricks on, for instance, a DS v3 as it would to run a VM on a DS v3 or Azure ML. So this is all like super commodified, super, cloudy, for lack of a better word. And it's a true platform as a service offering. So there's no flag on the Microsoft side that's saying like, oh, this is for Databricks. Let's, charge them an extra 25%.
That's really good news.
Yeah, well, and so this might be me pulling down my pants a little bit, but let's go ahead and hop back into let's hop back into this, and you can actually see under cost management. We'll look at the resource group for the last couple months at Mixer. Because I think that's a great question. So if I go into my cost analysis, and I want to scope it to Mixer. If it'll take my scope, there we go. So we'll see for the last month, I've spent $12. And if we expand it out to the last 3 months, I think that's pretty consistent. Yeah. So like you've seen, what I've been doing all summer to make a data lakehouse from scratch, and it cost me all $45. So it's I don't want to criticize any other tools, but I will say it's not nearly as expensive as it would be to learn something like Synapse, where you're using like this really high concurrency, high throughput model, and there's no scaling up or out. So as long as you're not going into Databricks and picking like the biggest of everything, it's remarkably cheap.
Cool stuff.
Yeah, any other questions from the floor? If not, I'll give you a little bit of time back. Thanks everyone for tuning in. We're not going to be here next month because of Thanksgiving, but we'll be back in December with the next portion of Databricks 101. Thanks everyone for coming.
All right, Spencer, can you stay online and help me out here?
Yeah, just give me a call once I hop off.
Okay. Yeah, thanks.
Thanks.